Welcome to an incredible journey through time, where dinosaurs ruled the Earth. In the next few minutes, you'll discover 100 amazing facts about these prehistoric giants, from fierce predators to gentle giants, and from tiny, clever hunters to enormous plant-eaters. Get ready to explore their world, uncover their secrets, and see dinosaurs like never before. Chapter 1. Dinosaurs roamed the Earth over 230 million years ago. Some were as small as chickens, while others, like Argentinosaurus, stretched longer than 100 feet. Fossils reveal their diversity, from feathered hunters to giant plant-eaters. Scientists study bones and teeth to understand how they moved, hunted, and even how fast some could run. Imagine a world dominated by these incredible giants. Chapter 2. Tyrannosaurus rex had one of the strongest bites in history, powerful enough to crush bone. Its tiny arms were surprisingly strong for their size, possibly used to hold prey. Fossil evidence shows T-Rex grew rapidly, gaining hundreds of pounds each year. Some scientists believe T-Rex may have hunted in packs, while others think it scavenged. Its roar echoes through imagination today. Chapter 3. Velociraptors weren't huge movie monsters. They were about the size of a turkey. They had feathers, sharp claws, and highly intelligent hunting skills. Fossils indicate they may have used strategy when attacking prey. Their brain size relative to their body suggests they were among the cleverest dinosaurs. These tiny predators paint a different picture than Hollywood ever showed. Chapter 4. Some dinosaurs had feathers, not just birds. Fossils like those of Microraptor show feathered wings, possibly used for gliding between trees. Feathers weren't always for flight. They could help with temperature regulation or courtship displays. This discovery blurs the line between dinosaurs and modern birds, showing evolution's surprising twists. Colorful plumage might have made Jurassic forests more vibrant than we imagined. Chapter 5. Stegosaurus had bony plates along its back, which weren't just for protection. Some scientists think they regulated body temperature like natural radiators. Its spiked tail, the thagomizer, was a deadly defense against predators. Despite its large size, Stegosaurus had a tiny brain about the size of a walnut, showing that body size doesn't always equal intelligence. Ancient forests were its hunting grounds. Chapter 6. Brachiosaurus had a long neck that allowed it to reach treetops others couldn't. Unlike other giant dinosaurs, its front legs were longer than its back legs, giving it an upright posture. Scientists study bone structure and fossils to estimate its massive weight up to 80 tons. Despite its size, it moved slowly, grazing peacefully. The image of towering giants still fascinates paleontologists today. Chapter 7. Some dinosaurs, like Ankylosaurus, were living tanks. Their bodies were covered with armor plates and a club-like tail for defense. Fossils suggest Ankylosaurus survived many predator attacks because of this unique design. Paleontologists reconstruct their lifestyle to understand how defense shaped evolution. Every armored scale tells a story about survival in a dangerous prehistoric world. Chapter 8. Pachycephalosaurus had a thick, domed skull, possibly used for head-butting. Scientists debate whether it was for fighting rivals, attracting mates, or both. Fossils show healed injuries, hinting at aggressive behavior. This dome-shaped skull is one of the strangest adaptations in dinosaur history. Imagine these creatures clashing heads in prehistoric fields, competing for dominance or attention. Chapter 9. Spinosaurus may have been the only semi-aquatic dinosaur, hunting fish in rivers and lakes. Its long, crocodile-like snout and conical teeth were perfect for catching slippery prey. Fossils reveal a sail-like structure on its back, possibly for display or thermoregulation. This predator challenges our perception of dinosaurs, showing they could thrive in water as well as on land. Chapter 10. Some dinosaurs laid eggs in massive nests, sometimes with hundreds of eggs. Fossils of dinosaur embryos show that young had different features than adults. Parental care might have existed in some species, protecting eggs and teaching hatchlings survival skills. Studying these nests helps scientists understand social behavior, growth, and family life millions of years ago. Dinosaurs. Chapter 11. Triceratops had 3 horns on its face and a large frill at the back of its skull. The horns could defend against predators like T-Rex, while the frill may have attracted mates or protected the neck. Fossils show healed horn injuries, hinting at battles. These herbivores roamed in herds, making prehistoric plains alive with movement and strategy. Chapter 12. Oviraptor's name means egg thief, but fossils suggest it might have protected its own eggs. Its beak-like mouth allowed it to eat plants, small animals, or eggs. Fossilized nests show adults sitting over eggs, hinting at parental care. This small, feathered dinosaur challenges old misconceptions, showing that even tiny species played critical roles in the ecosystem millions of years ago. Chapter 13. Diplodocus had one of the longest tails among dinosaurs, which could whip as a weapon or communication tool. Its long neck allowed it to graze over wide areas without moving much. Fossils suggest it traveled in herds for protection. With a small brain relative to its body, Diplodocus relied on instinct and social behavior to survive in prehistoric landscapes. Chapter 14. Allosaurus was a top predator before T-Rex appeared. Its sharp teeth and strong jaw allowed it to hunt herbivores efficiently. Fossils show healed bite marks, hinting at battles with rivals or prey. Paleontologists study bone fractures to understand predator-prey dynamics. Allosaurus gives us insight into how dinosaurs adapted and evolved to dominate their environments millions of years ago. Chapter 15. Parasaurolophus had a long, curved crest on its head, possibly used to make sounds for communication. Fossils suggest it could amplify calls to warn of predators or signal herd movements. This duck-billed dinosaur grazed in large groups, demonstrating complex social behavior. Its unique crest reminds us that dinosaurs were not only fierce or huge, they could be creative and socially interactive too. Chapter 16. The Rhizinosaurus had enormous, scythe-like claws up to 3 feet long. Though terrifying, it was mostly a plant eater. These claws may have helped pull down branches or defend itself. Fossil studies show unusual body proportions, with long arms and small heads. Its bizarre appearance challenges the traditional scary predator image, showing that evolution could produce strange but effective designs. Chapter 17. Irritator, a small spinosaurid, lived near rivers and hunted fish. Fossils show its elongated snout and conical teeth ideal for catching slippery prey. Its discovery highlights how diverse life was in ancient rivers and floodplains. Small adaptations like snout shape can reveal what dinosaurs ate and how they competed. Even minor species played a vital role in prehistoric ecosystems. Chapter 18. Carnotaurus had small horns above its eyes and tiny arms even smaller than T-Rex. Its fast, muscular legs suggest it could sprint to catch prey. Fossils show deep skull grooves, hinting at powerful jaw muscles. This predator's unusual build makes it one of the strangest-looking carnivores. It proves evolution sometimes favored speed and vision over brute strength and size. Chapter 19. Sauropods laid eggs in huge nesting grounds, sometimes over hundreds of meters. Fossils reveal patterns of communal nesting, hinting at social coordination. Young sauropods grew quickly to avoid predators, feeding alongside their parents in some species. Studying these nests gives scientists insight into reproduction, growth rates, and herd behaviors of some of the largest creatures ever to walk Earth. Chapter 20. Compsognathus was tiny, no bigger than a turkey, but a skilled hunter of insects and small animals. Its speed and agility helped it survive among larger predators. Fossils suggest feathered covering for warmth or display. Even the smallest dinosaurs adapted brilliantly to their environments, proving that survival relied not on size alone, but intelligence, speed, and cunning strategies millions of years ago. Chapter 21. Hadrosaurus, the duck-billed dinosaur, had hundreds of teeth for grinding plants. Fossils show it lived in herds, likely migrating for food and safety. Its flat bill helped scoop vegetation efficiently. Scientists study bone growth rings to estimate age and development. Hadrosaurus, social behavior and feeding strategies reveal a complex life beyond just size, showing dinosaurs had intelligence and cooperation in herds. Chapter 22. Megalosaurus was one of the first dinosaurs ever named. It was a medium-sized predator with sharp teeth and strong jaws. Fossil evidence suggests it hunted in forests and open plains, using speed and stealth. Studying its bones helps scientists understand early Jurassic predator behavior. Megalosaurus reminds us how paleontology shaped our understanding of dinosaurs and their evolution over millions of years. Chapter 23. Gallimimus could run up to 35 miles per hour, making it one of the fastest dinosaurs. Its long legs and lightweight body were perfect for escaping predators. Fossils show it had a small head and beak for eating plants or small insects. Speed and agility were survival tools, proving not all dinosaurs relied on size or strength to dominate their environment. Chapter 24. Cryolophosaurus, an early Jurassic predator, had a unique crest on its head. Fossils from Antarctica reveal that dinosaurs once lived in polar regions with long, dark winters. This dinosaur adapted to harsh climates with feathers and hunting strategies suited to its environment. Studying Cryolophosaurus shows dinosaurs were incredibly versatile, capable of thriving in extreme conditions long before modern mammals evolved. Chapter 25. Mamenchisaurus had one of the longest necks of any dinosaur, with up to 19 vertebrae. Its elongated neck allowed it to reach high trees and cover wide feeding areas without moving its massive body. Fossils suggest slow movement, grazing peacefully. This extreme adaptation demonstrates how evolution experimented with body structure, making some dinosaurs look almost unreal in proportion and design. Chapter 26. Dilophosaurus had a pair of thin crests on its head, which may have been used for display or mating rituals. It was a fast, agile predator hunting in forests. Fossils indicate lightweight bones and strong legs, showing hunting required speed and strategy. Dilophosaurus' unusual head ornamentation reveals how appearance could matter as much as strength in the dinosaur world. Chapter 27. Waranosaurus had a sail-like structure on its back, possibly for thermoregulation or display. Fossils show it was a herbivore that lived near rivers, eating leaves and aquatic plants. Its strong limbs allowed migration for food. This unique feature demonstrates that dinosaurs developed creative adaptations for survival. Evolution experimented with shapes and structures that would surprise even modern scientists. Chapter 28. Troodon was one of the most intelligent dinosaurs, with a large brain relative to its body. Fossils suggest keen eyesight, sharp claws, and fast reflexes, making it an effective hunter. Troodon may have hunted alone or in small groups, relying on strategy and agility. Intelligence in dinosaurs wasn't just for show. It shaped survival, hunting, and social interactions millions of years ago. Chapter 29. Kentrosaurus had spikes along its back and tail for defense against predators. Fossils indicate it lived in herds, which enhanced protection. Despite being small compared to giants like Brachiosaurus, Kentrosaurus used coordination and defense adaptations to survive. Studying its structure reveals how even medium-sized dinosaurs could thrive, proving evolution didn't rely solely on size or ferocity to ensure survival. Chapter 30. Deinonychus, a raptor-like predator, had a sickle-shaped claw on each foot for hunting. Fossils show strong legs and keen senses, suggesting pack hunting. Feathers may have provided insulation or display. This combination of speed, intelligence, and weaponry made it an effective predator. Deinonychus challenges old assumptions, showing that small dinosaurs could be deadly and complex hunters, not just minor creatures in prehistoric ecosystems. Chapter 31. Corythosaurus had a tall, helmet-like crest on its head that may have helped make sounds or attract mates. Fossils show it lived in herds, grazing on plants and ferns. Its hundreds of teeth allowed efficient chewing. This duck-billed dinosaur demonstrates how appearance and sound played roles in social communication, revealing that dinosaurs weren't just fierce. They were expressive and interactive creatures. Chapter 32. Giganotosaurus was one of the largest predators, bigger than T-Rex in length. Its skull was massive, with sharp teeth for slicing prey. Fossils suggest it hunted large herbivores in South America. Despite its size, it relied on speed and strategy rather than brute force alone. Giganotosaurus shows that evolution produced giants capable of dominating ecosystems through intelligence and adaptability. Chapter 33. Mononychus had tiny arms with a single claw, perfect for digging insects or burrowing. Fossils suggest it was a fast runner, adapted to desert-like environments. Its unique body plan shows that dinosaurs evolved for very specific ecological niches. Small, specialized dinosaurs like Mononychus remind us that survival wasn't always about size, but clever adaptations that allowed them to thrive in unusual habitats. Chapter 34. Maiasaura, the good mother lizard, cared for its young in communal nests. Fossils of embryos and juveniles reveal parental care, feeding, and protection. Its herds roamed plains, teaching survival skills to hatchlings. This dinosaur reshaped how scientists view dinosaur behavior, showing nurturing and social structures existed millions of years ago, far earlier than many expected. Chapter 35. Baryonyx had a long, crocodile-like snout filled with conical teeth for catching fish. Fossils suggest it lived near rivers and lakes, using claws to grab slippery prey. Its adaptations show that dinosaurs were not only terrestrial hunters, but could exploit water ecosystems too. Baryonyx demonstrates evolutionary creativity, turning a predator into a specialized fisher, bridging land and water hunting strategies. Chapter 36. Platysaurus was an early, long-necked herbivore that walked both on 2 and 4 legs. Fossils show it lived in herds and ate plants like ferns and conifers. Its flexible lifestyle allowed feeding versatility, giving it survival advantages. Studying Platysaurus helps paleontologists understand how early dinosaurs adapted to different environments, evolving into the massive sauropods that later dominated Earth. Chapter 37. Anzu, nicknamed the chicken from hell, had feathers, long legs, and a beak for eating plants and small animals. Fossils show a lightweight, agile predator with social behavior. Its appearance reveals that some dinosaurs looked eerily like giant birds. Anzu shows that evolution produced hybrid traits, speed, feathers, and intelligence, blurring lines between classic dinosaur and bird forms. Chapter 38. Waranosaurus had a distinctive sail along its back, likely used for thermoregulation or display. Fossils indicate it lived in herds near water, eating aquatic plants and leaves. Its unique structure demonstrates evolution's creativity, adapting for both survival and communication. The sail reminds us that dinosaurs experimented with body shapes, making some of the strangest but most functional adaptations in history. Chapter 39. Styracosaurus had a large frill with long spikes and a single horn on its nose. Fossils suggest it used this armor for defense and possibly for display or combat with rivals. Living in herds, Styracosaurus relied on protection and social behavior for survival. Its impressive headgear is a testament to how evolution combined offense, defense, and communication in one striking design. Chapter 40. Camarasaurus was a massive sauropod with a short, strong neck. Fossils show spoon-shaped teeth for chewing tough plant material. Its size protected it from predators, while herd living enhanced survival. Camarasaurus demonstrates that even large dinosaurs had strategies for feeding efficiency and social protection. Studying its bones reveals how gigantism and adaptation allowed some dinosaurs to dominate landscapes for millions of years. Chapter 41. Pteranodon wasn't a dinosaur but a flying reptile living alongside them. Its wings spanned over 20 feet, perfect for gliding over oceans in search of fish. Fossils show a crest on its head, likely for balance or display. Pteranodon highlights how prehistoric skis were filled with giants, and dinosaurs shared their world with remarkable aerial predators. Chapter 42. Troodon had one of the largest brains relative to body size, making it one of the smartest dinosaurs. Fossils suggest keen eyesight, sharp claws, and fast reflexes for hunting. Its intelligence may have allowed complex hunting strategies and social interactions. Troodon proves that survival relied not just on strength, but also on cleverness, planning, and adaptability in prehistoric ecosystems. Chapter 43. Sauropelta was an armored dinosaur with spikes along its body for defense. Fossils indicate it lived in herds to protect against predators. Its small head and slow pace were balanced by strong armor and clubbed tail. Sauropelta demonstrates how dinosaurs evolved defense mechanisms instead of relying solely on speed or aggression to survive, showing adaptation in action. Chapter 44. Oviraptor was initially thought to steal eggs, but fossils reveal it cared for its own. Sitting on nests, it protected eggs and possibly warmed them. Its beak allowed a mixed diet of plants, insects, and eggs. Oviraptor highlights the complex behaviors of small dinosaurs and shows that nurturing instincts existed millions of years ago. Chapter 45. Irritator, a small spinosaurid, hunted fish near rivers with its long snout and conical teeth. Fossils indicate strong jaws and adaptations for aquatic life. Its hunting style shows how dinosaurs exploited water ecosystems, not just land. Even small predators had specialized traits, proving survival often depended on niche adaptation and clever evolution rather than sheer size or strength. Chapter 46. Chasmosaurus had a large frill and two long brow horns for defense and display. Fossils suggest herd living, where group protection enhanced survival. Its frill may have communicated social signals or attracted mates. Studying Chasmosaurus reveals how horned dinosaurs combined defense, communication, and social behavior, showing evolution's intricate creativity in prehistoric life. Chapter 47. The Rhizinosaurus had enormous claws, some over 3 feet long, mainly for pulling plants or defending itself. Fossils show long arms, small heads, and unique body proportions. This herbivore's bizarre appearance proves evolution experimented with extreme adaptations. Its claws remind us that survival doesn't always require hunting. Sometimes defense and feeding tools shape a species' success. Chapter 48. Velociraptor, feathered and agile, was a clever predator. Fossils suggest it hunted small prey with speed and intelligence, possibly in groups. Its sickle-shaped claw was deadly, and feathers provided warmth or display. Velociraptor challenges old assumptions about dinosaurs as only giant monsters, revealing small, feathered species were fast, intelligent, and adaptive hunters. Chapter 49. Sauropods like Apatosaurus had long necks to reach treetops and graze over wide areas. Fossils show herd behavior and slow, steady movement. Their massive size offered protection, while social dynamics improved survival. Apatosaurus highlights gigantism and adaptation, showing how dinosaurs combined size, feeding strategies, and cooperation to thrive in prehistoric forests and plains. Chapter 50. Carnotaurus had tiny arms, strong legs, and horns above its eyes. Fossils show it was a fast predator, relying on vision and speed. Its unusual build challenges classic predator images, proving evolution favors specialization. Carnotaurus demonstrates that even fearsome hunters relied on strategy, agility, and unique adaptations to dominate their habitats millions of years ago. Chapter 51. Albertosaurus was a relative of T-Rex but smaller and faster. Fossils suggest it hunted in packs, targeting large herbivores. Sharp teeth and strong jaws made it an effective predator. Its hunting strategies hint at social coordination, showing that even fearsome predators sometimes relied on teamwork to survive in prehistoric ecosystems millions of years ago. Chapter 52. Dilophosaurus had two thin crests on its head, possibly for display or attracting mates. Fossils indicate it was a fast, agile hunter. Lightweight bones and long legs suggest it relied on speed and stealth rather than brute strength. Dilophosaurus proves that evolutionary adaptations often favored appearance and agility alongside hunting efficiency. Chapter 53. Parasaurolophus had a long, curved crest that could produce sounds to communicate with its herd. Fossils show it lived in groups, grazing on plants. The crest may have amplified calls for warnings or social interactions. Parasaurolophus demonstrates how dinosaurs used body features for both survival and communication, revealing complex social behavior in prehistoric times. Chapter 54. Deinonychus had a sickle-shaped claw on each foot for hunting. Fossils indicate strong legs, agility, and intelligence, suggesting it may have hunted in packs. Feathered covering provided warmth or display. This predator shows that small dinosaurs could be deadly, smart, and coordinated, challenging the image of dinosaurs as only solitary or large threats. Chapter 55. Coelophysis was a slender, fast predator living in herds. Fossils show sharp teeth and lightweight bones, ideal for catching small prey. Evidence of cannibalism exists in some specimens, indicating survival pressures. Coelophysis highlights how early dinosaurs adapted hunting strategies and social behavior to survive, showing evolution's trial and error approach in prehistoric ecosystems. Chapter 56. Sauropods like Brachiosaurus had long necks for reaching treetops. Fossils indicate it spent hours feeding in forests. Its massive body deterred predators, and herd living increased safety. Brachiosaurus demonstrates how size, feeding strategy, and social behavior combine to dominate ecosystems, highlighting evolution's ability to create giants adapted to specific ecological niches. Chapter 57. Oviraptor cared for its eggs, sitting over nests to protect and warm them. Fossils reveal feathers and beak adaptations for a mixed diet. Its behavior shows parental care existed in some species, revealing complex social structures. Oviraptor challenges old misconceptions about dinosaurs being solely aggressive or indifferent toward their young. Chapter 58. Irritator hunted fish with a long, narrow snout and sharp conical teeth. Fossils suggest it lived near rivers and lakes. Its adaptations show some dinosaurs specialized for aquatic hunting. Even small predators had unique traits, proving survival often depended on niche adaptation and specialized feeding techniques rather than size or strength alone. Chapter 59. Kentrosaurus had spikes along its back and tail to defend against predators. Fossils show herd living for enhanced protection. Its defensive adaptations allowed survival in dangerous ecosystems, despite modest size. Kentrosaurus demonstrates how evolution relied on armor, coordination, and strategy, proving survival depended on more than brute force in prehistoric landscapes. Chapter 60. The Rhizinosaurus had huge claws, likely for pulling down plants or defending itself. Fossils show long arms, small head, and unique body structure. This bizarre dinosaur proves evolution experimented with extreme adaptations. Survival sometimes depended on specialized tools, not hunting, showing how herbivores evolved unexpected features to thrive millions of years ago. Chapter 61. Camarasaurus had a short, strong neck and spoon-shaped teeth for chewing tough plants. Fossils indicate herd living for protection and social interaction. Its massive size deterred predators, while feeding strategy allowed efficient energy use. Camarasaurus highlights how gigantism and adaptation work together, showing that even the largest dinosaurs evolved smart ways to survive and thrive in ancient ecosystems. Chapter 62. Styracosaurus had a spiked frill and a large nose horn for defense and display. Fossils suggest herd living, using social dynamics to survive. Its frill may have communicated status or attracted mates. Studying Styracosaurus shows that horned dinosaurs combined defense, appearance, and social behavior, proving evolution's creativity in shaping both survival and communication features. Chapter 63. Giganotosaurus, one of the largest predators, had a massive skull with sharp teeth for slicing prey. Fossils show it hunted large herbivores, relying on size and speed. Its adaptations highlight how evolution produced giants capable of dominating ecosystems. Giganotosaurus proves that size alone wasn't enough. Coordination, hunting strategy, and intelligence were crucial for prehistoric predators. Chapter 64. Mononychus had tiny arms with a single claw, likely for digging insects. Fossils suggest it was fast, agile, and adapted to arid environments. Its specialized body plan shows dinosaurs evolved for specific ecological niches. Mononychus reminds us that survival often depended on clever adaptations rather than size, revealing the diversity and innovation of dinosaur evolution. Chapter 65. Maiasaura, the good mother lizard, cared for its young in communal nests. Fossils of embryos show parental care, feeding, and protection. Herd behavior helped teach hatchlings survival skills. Maiasaura highlights complex social structures and nurturing instincts, reshaping our understanding of dinosaur behavior millions of years ago. Some dinosaurs were as caring as modern birds or mammals. Chapter 66. Baryonyx had a long snout and conical teeth for catching fish. Fossils suggest it lived near rivers and lakes, using claws to grab slippery prey. Its adaptations show dinosaurs could exploit water ecosystems as well as land. Baryonyx demonstrates evolution's creativity, turning predators into specialized fish hunters, bridging terrestrial and aquatic survival strategies. Chapter 67. Platysaurus, an early herbivore, could walk on 2 or 4 legs. Fossils show herd living and adaptability in feeding. Its flexible lifestyle allowed it to reach various plants and escape predators. Studying Platysaurus helps scientists understand how early dinosaurs evolved into massive sauropods, showing evolution's gradual experimentation with mobility and survival strategies. Chapter 68. Anzu, called the chicken from hell, had feathers, long legs, and a beak for eating plants and small animals. Fossils show a fast, agile predator with possible social behavior. Its bird-like appearance demonstrates that evolution produced hybrid traits, combining intelligence, speed, and feathers. Anzu shows dinosaurs were diverse, creative, and sometimes unexpectedly bird-like. Chapter 69. Waranosaurus had a sail along its back, possibly for thermoregulation or display. Fossils suggest it lived in herds near water, eating aquatic plants. The sail illustrates evolution's creativity in adapting dinosaurs to environmental needs. Waranosaurus shows how survival sometimes required both protection and communication, turning a simple structure into a multifunctional evolutionary advantage. Chapter 70. Chasmosaurus had a large frill and long brow horns for defense and display. Fossils indicate herd living for protection and social coordination. Its frill may have communicated status or attracted mates. Chasmosaurus shows that evolution combined physical defense with social and communication strategies, highlighting the multifaceted survival tools dinosaurs developed over millions of years. Chapter 71. Velociraptor was feathered, small, and agile, hunting prey with speed and intelligence. Fossils suggest it may have used strategy and pack behavior to catch larger animals. Its sickle-shaped claw and keen senses made it deadly despite its size. Velociraptor shows that even tiny dinosaurs could dominate with brains, agility, and adaptation, not just sheer strength. Chapter 72. Sauropods like Diplodocus had extremely long tails, possibly for defense or communication. Fossils show herd living and slow, steady movement while grazing. Their necks allowed them to reach high or low vegetation efficiently. Diplodocus highlights how gigantism and social behavior combined, showing evolution's creativity in balancing size, feeding strategy, and group survival in prehistoric forests. Chapter 73. Tyrannosaurus rex had one of the strongest bites ever, able to crush bone. Fossils show rapid growth rates and tiny yet strong arms. T. rex may have hunted alone or scavenged, relying on intelligence and powerful jaws. Its dominance proves that evolution combines strength, strategy, and physiology to create apex predators capable of shaping entire ecosystems. Chapter 74. Triceratops had 3 horns and a large frill, used for defense and display. Fossils suggest herd behavior and healed injuries from battles. The frill may have been used to attract mates or signal dominance. Triceratops shows that physical adaptations and social behavior work together, creating a complex survival strategy for herbivores facing deadly predators. Chapter 75. Oviraptor, initially thought to steal eggs, actually cared for its own. Fossils show nesting behavior, parental care, and possibly warm incubation. Its beak allowed a mixed diet of plants, eggs, or insects. Oviraptor proves that some dinosaurs displayed nurturing behavior, reshaping ideas about prehistoric social life and showing small dinosaurs were capable of complex interactions. Chapter 76. Spinosaurus may have been semi-aquatic, hunting fish with its long snout and conical teeth. Fossils suggest a sail-like structure on its back for display or thermoregulation. Its adaptations demonstrate that dinosaurs thrived in diverse habitats, including rivers and lakes. Spinosaurus shows evolution's flexibility, producing creatures capable of dominating both land and water environments. Chapter 77. The Rhizinosaurus had enormous claws, probably for pulling plants or defense. Fossils reveal long arms, small heads, and unique body structures. This herbivore challenges traditional predator-focused images, showing evolution favored extreme adaptations for survival. Its claws are examples of nature's creativity, proving dinosaurs evolved tools beyond hunting for thriving in harsh ecosystems. Chapter 78. Allosaurus, a top Jurassic predator, had sharp teeth and strong jaws. Fossils show healed bite marks, suggesting aggressive interactions. It hunted large herbivores, relying on speed, strategy, and sharp senses. Allosaurus illustrates how predators adapted to ecosystems, demonstrating intelligence and physical ability working together to survive in a competitive prehistoric world. Chapter 79. Gallimimus could sprint up to 35 miles per hour, using speed to escape predators. Fossils indicate long legs, lightweight body, and small beak for eating plants or insects. Its agility shows that survival depended not only on size or strength, but also on speed, flexibility, and strategy. Gallimimus demonstrates evolution's focus on diverse adaptations for different ecological roles. Chapter 80. Irritator, a spinosaurid, hunted fish in rivers with a long, narrow snout and conical teeth. Fossils show adaptations for aquatic hunting, including claws for grabbing slippery prey. Its lifestyle reveals that even small predators specialized in niches, demonstrating evolution's role in creating variety and efficiency. Irritator highlights how dinosaurs mastered both land and water ecosystems. Chapter 81. Pachycephalosaurus had a thick, domed skull, possibly used for headbutting rivals or attracting mates. Fossils show healed injuries, suggesting aggressive behavior. Its small brain didn't stop it from being an effective competitor. Pachycephalosaurus demonstrates how evolution created strange but functional adaptations, combining defense, mating strategies, and survival in a unique headgear design. Chapter 82. Brachiosaurus had a long neck and front legs taller than its back legs, allowing it to reach high treetops. Fossils suggest slow movement while grazing on trees. Its enormous size protected it from predators, while herd behavior provided social safety. Brachiosaurus shows gigantism and adaptation combined to dominate ecosystems in both feeding strategy and defense. Chapter 83. Stegosaurus had bony plates along its back, likely for thermoregulation or display, and a spiked tail for defense. Fossils show a tiny brain compared to its massive body. Despite this, Stegosaurus thrived using physical adaptations. Its combination of defense and appearance demonstrates evolution's creative solutions, highlighting survival strategies beyond intelligence or speed in prehistoric times. Chapter 84. Compsognathus was a small, agile predator, roughly the size of a turkey. Fossils suggest it hunted insects and small animals with speed and precision. Feathered covering provided warmth or display. Its survival relied on cleverness and agility, not size. Compsognathus reminds us that even the tiniest dinosaurs evolved traits to dominate ecological niches effectively. Chapter 85. Carnotaurus had small arms, strong legs, and horns above its eyes. Fossils indicate it relied on speed and vision to hunt. Its unusual build shows that predators didn't need large arms to be effective. Carnotaurus proves evolution favored specialization, where strategy, agility, and physical adaptations were more important than brute force in dominating prehistoric environments. Chapter 86. Albertosaurus, smaller than T-Rex, was a fast predator with sharp teeth and strong jaws. Fossils suggest it may have hunted in packs, using coordination to tackle large prey. Its hunting strategy highlights social behavior in predators, showing that even fearsome dinosaurs depended on teamwork, speed, and cunning to survive in competitive ecosystems millions of years ago. Chapter 87. Diplodocus had a long tail and neck, grazing on vegetation over large areas. Fossils indicate herd behavior and slow, steady movement. Its body design allowed efficient feeding without moving excessively. Diplodocus demonstrates how gigantism, feeding strategy, and social behavior combined, showing evolution's ingenuity in balancing size, efficiency, and survival in prehistoric landscapes. Chapter 88. Tyrannosaurus rex had one of the most powerful bites ever. Fossils show rapid growth, tiny arms, and massive skull strength. T-Rex may have scavenged or hunted alone, using strategy and brute force. Its dominance proves that apex predators combined physiology, behavior, and intelligence, shaping ecosystems and demonstrating evolution's ability to create ultimate hunters. Chapter 89. Triceratops had 3 horns and a large frill for defense and social signaling. Fossils indicate healed injuries and herd behavior, revealing interactions with predators and rivals. Its frill may have attracted mates or established dominance. Triceratops shows that physical adaptations and social behavior work together, creating complex survival strategies for herbivores facing dangerous predators. Chapter 90. Oviraptor cared for its eggs, sitting on nests to protect and warm them. Fossils show feathers and a versatile beak for eating plants, insects, or eggs. Its behavior demonstrates parental care in small dinosaurs, revealing social complexity. Oviraptor challenges old misconceptions, showing nurturing instincts existed millions of years ago, and that small dinosaurs had intricate social lives. Chapter 91. Spinosaurus may have been semi-aquatic, hunting fish in rivers and lakes. Fossils show a long snout with conical teeth and a sail on its back for display or thermoregulation. Its adaptations reveal evolution's creativity, showing dinosaurs could thrive in water as well as land. Spinosaurus demonstrates flexibility and specialization in prehistoric predators. Chapter 92. The Rhizinosaurus had massive claws, likely used for pulling down plants or defending itself. Fossils show long arms, small heads, and unique body structure. This bizarre herbivore proves evolution favored extreme adaptations. Its claws illustrate that survival sometimes relied on tools beyond hunting, demonstrating creativity in prehistoric herbivore adaptations. Chapter 93. Allosaurus, a top predator before T-Rex, had sharp teeth and strong jaws. Fossils indicate healed bite marks, hinting at aggressive interactions. It hunted large herbivores with speed and strategy. Allosaurus illustrates how predators combined physical ability with intelligence, showing evolution produced effective hunters adapted to competitive Jurassic ecosystems. Chapter 94. Gallimimus could sprint up to 35 miles per hour, relying on speed to escape predators. Fossils show long legs and a lightweight body, with a small beak for eating plants or insects. Agility was key to survival. Gallimimus demonstrates how evolution favored speed, strategy, and versatility in small to medium-sized dinosaurs for protection and feeding efficiency. Chapter 95. Irritator hunted fish in rivers with a long, narrow snout and conical teeth. Fossils suggest claws for grabbing slippery prey. Its specialization shows small predators could exploit aquatic niches. Irritator highlights evolution's role in creating efficient and versatile hunters, proving survival required more than size or brute force, relying instead on adaptation to unique environments. Chapter 96. Pachycephalosaurus had a thick, domed skull used for headbutting rivals or attracting mates. Fossils show healed injuries, suggesting aggressive behavior. Its small brain didn't prevent it from being effective. Pachycephalosaurus illustrates evolution's creativity, combining defense, competition, and survival strategies into a unique headgear adaptation. Chapter 97. Brachiosaurus had a long neck with taller front legs, allowing it to reach treetops easily. Fossils indicate slow movement while feeding in forests. Its size protected it from predators, while herd living added social safety. Brachiosaurus demonstrates gigantism combined with feeding strategy and social behavior to dominate ancient ecosystems effectively. Chapter 98. Stegosaurus had bony plates along its back, possibly for thermoregulation or display, and a spiked tail for defense. Fossils show a tiny brain relative to its body. Despite this, it thrived using physical adaptations. Stegosaurus demonstrates evolution's creative solutions for survival beyond intelligence or speed, combining defense and visual display in one design. Chapter 99. Compsognathus, a tiny predator the size of a turkey, hunted insects and small animals. Fossils suggest speed and agility were key to survival, with feathered covering for warmth or display. Its survival relied on clever adaptations, proving that even the smallest dinosaurs were effective hunters in their ecosystems, thriving through intelligence and mobility rather than size. Chapter 100. Tyrannosaurus rex had a massive bite and grew rapidly, becoming one of the deadliest predators ever. Fossils show tiny arms but powerful jaws capable of crushing bone. T-Rex may have hunted alone or scavenged, using strategy and brute force. Its dominance proves evolution combined physiology, behavior, and intelligence to create apex predators that ruled prehistoric ecosystems. Thanks for watching. Now you know 100 fascinating facts about dinosaurs and their extraordinary world. If you enjoyed this journey through prehistory, don't forget to like, share, and subscribe for more amazing stories from the past. Keep exploring, stay curious, and remember, the world of dinosaurs is full of surprises waiting to be discovered.